In this video, we will be forecasting cycles for gasoline sales. So this is a continuation from forecasting trends and seasonality. So the data has been split for in-sample, out-of-sample, and forecast horizon. We already previously did linear and quadratic trend, and then also looked at each of the trends with seasonality and found quadratic trend with seasonality with the most optimum. Next, we're going to look at different cycles, AR1, AR2, MA1, MA2, and ARMA 1-1. So let's take a quick look at the gasoline series. So this is what it looks like. Looks like there are sharp, there's a trend and there's seasonality, but there's some presence of cycles, or at least it appears to be. This is the model with quadratic trend and seasonality. You can see in the residuals, there again seems to be certain cyclical component to it. Go back to estimate, and I'm going to copy this equation so I can add a cycle to the quadratic trend and seasonality. So quick estimate equation, paste. So here I have all the dummy variables, time and time squared, no constant because it has 12 for each month, 12 dummy variables, 1 for each month. It'll first fit in the in sample, so up to 1998, month 4. And just to capture an AR1 model, you type in AR parentheses 1. Okay, there you go. You'll see the AR1 at the very bottom. The coefficient related to AR1 looks like it's significant. Okay, I'm going to copy the key statistics. So first, let's get the adjusted R squared. 0.9856, the AIC and the SIC. The AIC and then SIC. Control C, Control V. Okay, you can see the adjusted R square improved quite a bit from the previous models that are presented. Now let's work on the in-sample root mean squared error and the out-of-sample root mean squared error. Forecast, and then in-sample, that's up to 1998. Month 4, uncheck the box, forecast and actuals. Okay. Alright. I'm going to capture the root mean squared error, 602.0888. So I'll type this into Excel. Okay, next let's go in and estimate the out of sample. So back to EViews. Alright, forecast, and then this time it will be the out of sample. Right, uncheck the box. So let me copy paste the out of sample range. Okay. Control V, uncheck the box, and then forecast and actuals. Okay. Let's get the out of sample root mean squared error. So copy, and then let's go ahead and paste that. Okay. Now we have our AR1 model. Let's work on our AR2. So I'm going to name this equation as just AR1. Alright, next let's estimate, and AR1 and then AR2. So a new equation, copy pasted it to make it a bit easier. Right, so quick estimate equation. Paste the previous equation, and then to AR1 I'm going to add an AR2. Change the sample to 1998, so keep that as it is. LS ARMA, so this to 1998 April. Okay, now we have both AR1 and AR2. Let's look at the residuals so you can see how it fits the data, the in sample quite well. The residual doesn't seem like there is any pattern. There could be, but it's not evidently clear. Right, let's grab the adjusted R squared. And the AIC. And then SIC. Perfect. Let's now go and forecast to get the in sample root mean squared error. Changing the sample to 1998, month 4. Uncheck and forecast and actuals. Okay. Let's get the out of sample root mean squared error, so 591.1587. Let's put that in Excel. Sorry, that's the in sample, 591.1587. Now we're going to work on the out of sample. Let me name this equation AR2. Oh, just without the parentheses, to just AR2. Okay. Alright, let's go back to AR2. I skipped a part here, so I'm going to now be forecasting the out of sample to get the out of sample root mean squared error. So in forecast, replacing this with the out of sample, unchecking the box, forecast and actuals. Okay, let's copy paste the root mean squared error. So 1652, we'll get that and then put that in Excel. Okay. Perfect. We have everything for an AR2. Next, we are going to work on an MA1. Right, out of the two, looks like our AR2 is slightly better. The in sample and out of sample root mean squared are much smaller. Okay. Let's work on the MA1 now. So I'll copy the first part of the equation. It just makes it easier. Now let's go to quick estimate equation. And then Control V. And at the end for MA1 process, I'll just add MA parentheses 1. I don't know if I changed the sample. No, I did not. So let me go back and change that to 1998, March 4, for it to be an in sample. Okay, there we go. We have our MA. Okay, let's look at the residuals real quick. You can see the actual and the fitted. The residual slightly looks like in the late 1980s. There still is a little bit of cycle. Okay. Let's change the date for our in sample root mean squared error. Uncheck. Forecast and actuals. Okay. We're gonna go ahead and grab the in sample root mean squared error. Let's get the 575.35 for our in sample root mean squared error. So we'll put this in Excel. Okay, just copy pasting that. Control C, and then going to Excel. So not the adjusted R squared, the in sample. I should probably capture those statistics too. Right, so now let's go and get the out of sample root mean squared error. Copy, paste. Uncheck the box, forecast and actuals. Okay. Let's get our root mean squared error. Right, pasting the out of sample root mean squared error. At this point, you should be able to get the adjusted R squared, AIC, and SIC, and the same for MA2 and ARMA 11. So I would just focus on showing the equation and just how to estimate that, and then come back and see the final part for it, like the actual forecast for it. So complete this one with the adjusted R square, AIC, and SIC. So adjusted R square, copy, paste, and then again the AIC, copy, paste, and then finally the SIC, copy, paste. For the MA2 and the ARMA 11, I will show you the estimation equations, and then I believe you should be able to do the rest. I'm going to save this as an MA1 equation. Let's look at the estimation for an MA2. So we have our trend, and then MA1, MA2, and the 12 dummy variables. Changing the sample to 1998. March of 4. So there you go. From here, I'm going to get some of the statistics, key statistics from the in sample and then out of sample. Next, I'll show you the estimation for ARMA 11. I've saved this equation as MA2. Next, we're going to work on ARMA 11. So this is the equation for the MA2 model. So quick estimate equation, Control V. So I have the MA1. I'm going to add an AR1. So an AR1. In place of MA2, I'm going to just put MA1. We change that to 1998. Month of 4. Everything from here is pretty similar to what we have been doing so far. Right, so we have our R1 and MA1. You can see the coefficients and the p-values. Let's take a quick look at the residuals. So it doesn't seem like there is much of the cycle left in the residuals, but you could also test this by looking at the correlograms of, there you go, for the residuals. So you can see most of it is inside something around the 4th period. That seems a little bit outside, but most of it is within the bands. So those are the ACFs and the PACFs of the residuals. Okay, so we have all our evaluation matrix. At this point, we can start comparing. Looks like this is the highest adjusted R-square is for AR 98.58 for AR2. The lowest AIC is 0.02068. So for AR1, same thing. The SIC is also for AR1. But the in sample and the out of sample, 575.35 for an MA1 process is the lowest. Let's mark that. And then for out of sample root mean squared error, it's not visible here, but it is also for the MA1 process. It looks like the out of sample, the root mean square statistics are better for MA1, and then the AR1 is better in terms of lower AIC and SIC. The adjusted R-square is also comparable to the AR2, so it's really between these two models, AR1 and MA1. But since the out of sample root mean squared error is much less, I would personally prefer to use that as the MA1 as a forecast model. So let's take a look at the forecast of these two series, AR1 and MA1, a little bit closely. Let's go back to EViews to look at the AR1 model. Okay, let's save this equation. So name it, I'll call it ARMA11. Okay, let's go to AR1. And change the estimation range to include all available data points, so up to 2001 month 4. Okay, and then change the estimation. Go ahead and do the forecast. So I want to save this forecast series, so I'll save it as AR1 forecast. Again, for the entire data and the forecast horizon. So as it was up to 2004. Insert actuals. Okay. Right, it has already saved the forecast, but I didn't plot it with the actuals, so I'm going to go ahead and plot it with the actuals. It has already been saved, so I don't have to do that part again. Okay. So as you can see, there are some parts that are slightly off from the forecast. The solid green, those are the actuals, but that's fine. You don't want to have a case of overfitting your data anyway. Let's do the same for the MA process. So for the MA1, go ahead and get forecast. Estimate equation, and then change the range to 2001 month 4. Go ahead and do the forecast. I'll save this as MA1 forecast. The entire forecast sample and horizon, keep that checked, and then up to 2004. Okay, forecast and actuals. Okay. Here too we see those slight instances where the ensample does not fit. So now I have my AR1 forecast and MA1 forecast. I'm going to highlight these three and open them as a graph. AR1, MA, and then gasoline sales. So graph. Okay. Alright, so the green is the GS and the other two are the forecast, MA1 and AR1. They almost overlap each other. So visually, I can't really tell the difference between the two. Yeah, it might be just best to go with the MA1 and to argue that it has lower root mean squared errors both in sample and out of sample and would make it an appropriate model for forecasting. Let's go ahead and save this graph. So let me not this, but let's freeze it first. So now freeze the not group. Yep. Freeze automatic. Okay. Alright, let's name the graph. Forecast graph cycles. Okay. Right now I have saved the graph, so now you know how to forecast cycles. So AR processes and then MA process and a combination of two.